Hi, and welcome to the tutorial video for the ANOVA Prelab for Stats 250. We're going to get started, as we always do, by opening our commander by in the R console typing library, open parenthesis, capital R, CMDR, close the parenthesis, and hit enter. So now that we've got our commander open, we're going to start by loading some data. To do this, we're going to come up to Data, Load Dataset, and in my Prelab 10 folder in Stats 250, I have a dataset here called shock.rdata. This is available on Canvas. We're just going to click Open here and click View Dataset to see what we're working with. So the shock dataset contains 64 observations of blood pressures grouped by different types of shock. So there's no shock. There's something called hypovolemic shock, which is when you have too little non-blood fluid in your bloodstream. Bacterial shock, also known as toxic shock, and neurogenic shock, which often happens after an injury to the central nervous system. So we're interested here in comparing mean blood pressures across these different types of shock. So the way that we're going to do this is by using ANOVA. So let's talk about how to perform ANOVA in R. So the first thing that we might want to do before we perform ANOVA is examine the data graphically. The best way to do this for this type of variable or this type of data is to create some side-by-side box plots. So to do that, we're going to come up to Graphs, Box Plot, and we're going to choose the B pressure variable. This is the blood pressure. And we're going to plot by groups and choose shock type. We can also come over to Options and provide a graph title here and choose whether or not we want to identify outliers. So let's click OK. And in the original R window or in an Xworks window on a Mac, you'll see these 4 side-by-side box plots appear. So we can see that there is perhaps some difference in the mean blood pressure across shock types. The none group seems to have a higher blood pressure on average. But we'll want to examine that statistically and see if there's a statistically significant difference between these 4 means. So let's go back to our commander, and we'll perform the ANOVA now. So to do that, we're going to come up to Statistics, Means, One-Way ANOVA. It's going to ask you to enter a name for the model. You can just leave this as the default. We want to choose shock type as the groups and B pressure as the response variable. You can click OK now. And now in the results window down here, it gives us some summary statistics as well as results of the ANOVA test. Remember that the null hypothesis for ANOVA is that all population means are equal across all the groups, and the alternative hypothesis is that at least one population mean is different from the others. Not that they're all different from each other, just at least one is different. So let's look specifically at this summary output here that gives us what's called an ANOVA table. So this sum squares column is the sum of squares, or SS on the formula card. This number here where it says shock type, this is the name of the groups variable, so this is SSG. This is the sum of squares for the groups, 13,045. SSE is 29,189. This is SSE. R, instead of calling it error, calls this residuals. So just know that this is your errors line in the formula card's ANOVA table. The degrees of freedom are here. So this is the degrees of freedom for the groups, and this is the degrees of freedom for the error. The mean squared values are here. So this is MSG, the mean squared groups, mean squared error. We get an F statistic here. This is quite a large F statistic, and now we get a p-value here. So this is quite a small p-value. So at the 5% significance level, for example, we would reject the null hypothesis that all of the groups have equal population mean blood pressures. Now you might be interested in seeing which groups are different. All this says is that at least one group is different from the others, has a different population mean from the other groups, so we might want to examine which differences there actually are. So to do that, we're going to come back up to Statistics, Means, One-Way ANOVA, and this time we're going to check this pairwise comparisons of means box, and click OK. Notice now we get the same, if you scroll up, the same output as before, We get summary statistics, an ANOVA table again, but now we also get this simultaneous test for general linear hypotheses. Don't necessarily have to worry about that. The key thing that we're going to look at right now is these confidence intervals here. So again, this will show up in your original R window. And what this is going to do is it's going to compare each group, their pairwise comparisons of each group, and we're interested in seeing which of these confidence intervals don't overlap 0. That's going to suggest that there is a significant difference between the two groups. So we can see that these first 3 confidence intervals don't overlap 0, which has this dotted line here. So it seems like there's a significant difference in mean blood pressure between the hypovolemic shock and no shock, bacterial shock and no shock, and neurogenic shock and no shock. So we can conclude for each of these group comparisons, these pairwise comparisons, that there is a significant difference in mean blood pressure between these two groups. We can also see this from the R output. Here it gives us each of our pairwise comparisons, as well as a t-test for each of these comparisons. So here we can see that the p-value for the t-test of the hypovolemic shock versus no shock is much less than 0.001. So at the 5% significance level, for instance, we would reject the null that there is no difference between hypovolemic shock and no shock in terms of population mean blood pressure. So now we can come over to our R Markdown document. We're going to scroll all the way up to the top. We're going to replace the main title with Prelab 10 ANOVA, your name here. We're going to come up to File, save our Markdown file as. I'm going to save this as Prelab 10 tutorial.rmd. Click Save, and then click Generate Report. So our report has been generated. It's appearing in the browser here. And this HTML file that appears in your file browser, here's the HTML file, for instance. This is what you're going to submit to Canvas, not anything that you save from your browser. So that concludes this week's tutorial. Let your GSI know if you're having any questions about this, and we're looking forward to seeing you in lab this week.